There is a quiet solitude in the vast emptiness of space, a silence that stretches for unimaginable distances. Yet, for nearly half a century, a tiny human-made object has been faithfully traversing this profound emptiness, carrying with it the hopes and curiosities of our species. This remarkable emissary is Voyager 1, launched in 1977. Its original mission was a grand tour of our outer solar system, a journey to visit the gas giants, Jupiter, Saturn. It was born from a rare alignment of the planets, a once-in-a-lifetime chance to slingshot a probe from world to world, revealing sights never before seen by human eyes. Voyager 1 performed its duties with breathtaking precision. But that was only the beginning. After Saturn, its mission changed to journey beyond the Sun's influence, to become the first human object in interstellar space. This was a voyage into the complete unknown. On board, it carries a very special artifact, a golden record. This phonograph holds sounds and images meant to portray life and culture on Earth. It contains greetings in 55 languages, the music of Bach, Chuck Berry, the sounds of waves, wind, whales, a message in a bottle cast into the cosmic ocean, a testament from a small, curious species on a pale blue dot. In August of 2012, after 35 years of travel, Voyager 1 finally achieved its extraordinary goal. It crossed the heliopause. The data it sent back confirmed the transition, detecting a much higher level of galactic cosmic rays, particles forged in distant supernovae. It had left the Sun's protective bubble and was now officially swimming in the sea of stars. In the grand, silent theatre of deep space, things tend to follow a predictable path, governed by the immutable laws of physics. So you can imagine the quiet astonishment in late 2024 when a decision was made to do something unprecedented. After years of careful planning and complex calculations, a series of commands was sent across billions of miles. The instructions, do something Voyager hadn't done in over 3 decades, turn around. This was no simple maneuver. The spacecraft is old, its systems are delicate, its power source was slowly fading. Every command carried risk. The team at NASA's Jet Propulsion Laboratory had to be certain. The goal, pivot the spacecraft just enough so the imaging science subsystem could face inward, back toward the distant point of light that is our Sun and its entire planetary system. The last time Voyager looked back was in 1990 to capture the pale blue dot. That photograph showed Earth as a minuscule pixel in a sunbeam, an iconic symbol of our fragility. The data confirmed it. Voyager 1 had successfully turned. Now it was looking homeward from beyond the frontier. With Voyager 1 now oriented towards home, a new phase of its mission began. It was not taking photographs in the conventional sense. From its immense distance, individual planets would be invisible. Instead, its instruments were calibrated to detect something far more subtle. They were programmed to measure faint variations in light, the distribution of charged particles. The initial data streams were, as expected, mostly noise. Scientists began the painstaking process of sifting through this data, searching for a signal. Weeks turned into months. The team analyzed the faint light signatures, looking for any coherent structure. The initial findings were inconclusive. There were slight fluctuations, hints of something, but nothing definitive enough to announce. It was like trying to hear a single soft whisper in the midst of a roaring crowd. But then, something began to emerge. As more data was collected and sophisticated algorithms were used to filter out the background noise, a pattern started to take shape. It was not a solid object or a sudden dramatic event. It was a subtle, persistent anomaly in the data. What Voyager 1 had detected was both astonishing and profoundly elegant. The data, when compiled and visualized, revealed what appeared to be a vast, stable tunnel or conduit of plasma. This structure, almost like a cosmic filament, seemed to extend from the edge of our heliosphere outward into the interstellar medium. It was not a physical, solid tube, but rather a channel of directed magnetic fields and contained particles. A sort of river flowing through the interstellar ocean. It was enormous, estimated to be many billions of miles in length, yet it was completely invisible to any observation from within the solar system. Scientists now believe this structure is a magnetic tunnel, a sort of cosmic highway. It appears to be a place where the magnetic field lines from our sun's heliosphere have become intertwined and aligned with the broader galactic magnetic field. This creates a protected pathway, a channel where particles can travel with less resistance. It acts as a bridge between our solar system and the local interstellar neighborhood. The discovery was shocking because it suggested that solar systems might not be isolated islands, but could be connected to their surroundings in ways we never imagined. The implications of this discovery extend far beyond just our own solar system. If our sun has such a magnetic tunnel connecting it to the local interstellar environment, it is highly probable that other stars do as well. This opens up the tantalizing possibility that the space between stars is not an empty void, but is crisscrossed by a vast, invisible network of these magnetic filaments. Our galaxy might be threaded with a cosmic web of these tunnels, connecting star systems to one another across immense distances. We may be living in a universe that is far more structured and interconnected on a local scale than we ever knew. These tunnels could serve as the primary conduits for the transport of matter and energy between star systems. They could guide the flow of cosmic rays, influence the formation of new stars, and perhaps even play a role in the distribution of the basic chemical building blocks of life throughout the galaxy. We may have stumbled upon the fundamental plumbing of our galactic neighborhood. It is a paradigm shift in our view of the interstellar medium. This discovery also provides a potential new area of study for the search for life beyond Earth. If these tunnels act as channels, they could transport organic molecules from one stellar system's protoplanetary disk to another. It suggests that the ingredients for life might be shared among stellar neighbors. Voyager 1's discovery, therefore, is not just about a strange feature of our own solar system. It is a clue to the fundamental nature of our galaxy. On a human level, a discovery of this magnitude invites us to pause and reflect on our place in this newly revealed cosmic structure. For all of recorded history, we have seen ourselves as living on a planet within a solar system that is largely isolated. We now have the first hints that this may not be the complete picture. We are connected to our galactic neighborhood in a way that is physical and direct. This magnetic tunnel is a real, tangible link between our home and the great wide universe beyond. This new understanding will undoubtedly fuel a new generation of scientific inquiry. Astronomers will now begin searching for evidence of similar structures around other stars. Future interstellar probes will be designed with instruments specifically meant to map these magnetic fields and understand how these tunnels form and behave. It opens up an entirely new field of astrophysics, the study of interstellar connectivity. This discovery underscores the immense value of long-term exploratory science. The Voyager mission was planned in the 1970s. No one at the time could have possibly conceived of this specific observation. Yet because we had the foresight to build a resilient and capable explorer, and the patience to guide it for decades, we were in a position to make this incredible finding. It is a powerful lesson that the greatest discoveries are often the ones we do not expect. The universe is endlessly surprising. It challenges our assumptions and rewards our curiosity with sights and ideas more wonderful than we could have imagined. We live in a cosmos that is not static or empty, but dynamic, interconnected, and filled with an elegance we are only beginning to appreciate. We are fortunate to live in an era where we can participate in such exploration, even from afar. As we continue to listen to the faint signals from our distant probe, we are reminded of the profound beauty of our world. The pale blue dot that Voyager showed us so many years ago. It is the starting point for all our journeys, the home our thoughts return to. The universe is waiting. Its wonders are there for us to find if we have the courage and patience to look. The story of Voyager is our story. Endless, breathtaking wonder. Please like and subscribe to Cosmic Discover.